Now we are discussing about the P block element 2. What are the chemical properties of ammonia? That is, first one is about the reducing properties. Reducing property of ammonia. The last class we discussed that what are the preparation of ammonia and what are the physical properties of ammonia and about what are the chemical properties about the action of heat and reaction with the air, etc. We'll discuss that one, and also preparation of nitrogen family, nitrogen, and what are the physical properties of nitrogen and what are the chemical properties of nitrogen and what are the uses of nitrogen. Okay, now we can discuss about the reducing property of ammonia and about the structure of ammonia. It's a very important question. Structure of ammonia and how is nitric acid prepared, lab preparation of nitric acid. So the very important question. I think that today these two questions are the assignment. Structure of ammonia and about the preparation of nitric acid. It's a very important question. Okay, please all of you take the book one by one. We can learn the reducing property of ammonia. Reducing property. Ammonia acts as a reducing agent. We know that ammonia is one of a good reducing agent. It reduces metal oxide to metal. For example, one of the metal oxide I am taking PbO, lead oxide. Am I right? This lead oxide is reduced into lead when we are adding ammonia. This ammonia, what is the formula of ammonia? NH3. PbO, lead oxide, to form PbO, that is lead oxide is reduced into Pb metal. And here I have nitrogen. Nitrogen is separated, and also hydrogen combines with oxygen. We get water molecule. How can we balance the equation? First, the reactant side, we can make it to ammonia. Am I right? So, because the product side N2 having, so the reactant side 2 ammonia we are using. So now nitrogen and also balance. Am I right? Next about the hydrogen. Here I have 2 into 3 is equal to 6. So the water molecules also make it 3 water molecules. Here I have 3 oxygen. Here also make it 3 oxygen. So 3 lead is balanced. Next, reaction with acid. What happens? Ammonia reacts with acid. Ammonia is treated with acid to form ammonium salt. Ammonium salt. Am I right? It may be an ammonium chloride, ammonium hydroxide, ammonium sulfate. Ammonium means NH4. Don't forget that. Ammonium. Okay. Anyhow, this reaction shows that the affinity of ammonia for proton is greater than water. Next, the reactions with the chlorine and chlorides. What happens? Ammonia reacts with the chlorine. And what happens? Ammonia reacts with the chloride. Can you understand the differences between? What happens? Ammonia reacts with the chlorine. Chlorine means Cl2. So what happens? Ammonia reacts with the chloride. Chloride means we can be taken as HCl, hydrogen chloride, like that. So here, ammonia reacts with the chlorine, we get hydrochloride. This hydrochlorides on reacts with ammonia, we get ammonium chloride. Okay, these reactions are under different condition. One is about that excess ammonia. That is, excess ammonia we are taking. Ammonia reacts with the chlorine to form ammonium chloride. First, we have to write the equation. One of an ammonia, this ammonia, NH3, reacts with Cl2 chlorine, we get dinitrogen, and also the hydrogen combines with the chlorine, we get hydrochloric acid. So you have to balance the equation. How can you balance the equation? Means the product side having nitrogen N2. So the reactant side nitrogen make it 2. So nitrogen is balanced. What about the hydrogen? Here having 6 hydrogen. So the product side also make it 6 hydrogen. Hydrogen is balanced. What about the chlorine? Here having 6 chlorine. So make it 3 Cl2. Chlorine balance. Now this hydrochloric acid, this HCl, reacts with ammonia. HCl means HCl, hydrochloric acid, reacts with ammonia, NH3, we get ammonium chloride. Here, before the equation HCl, they're having excess chlorine, that is a HCl, means we get a 6 molecule, am I right? So as per the equation, here having 6 molecules, the same molecules we are writing here. So same molecules we are writing here. So anyhow, we have to balance how the reaction is going and how can you balance. Hydrochloric acid reacts with ammonia, we get ammonium chloride, that is NH4Cl. So as per the previous reaction, they are having 6 moles, so we can be taken as here also 6 moles. 6 moles of hydrochloric acid, that is we can be change the product side also. Chlorine 6, am I right? So 6 molecules of ammonium chloride. So how much ammonia is there? 6 ammonia, so make it the reactant side 6 molecules. So that is the equation is balanced. So another one condition, ammonia reacts with the excess chlorine to give nitrogen trichloride. What is the formula? NCl3. What is the formula? NCl3. Nitrogen trichloride. This is one of an explosive substance. All of you know about the explosive substance. Am I right? Explosive, you know that one. We have to write the equation. Ammonia reacts with NH3 reacts with chlorine. We get nitrogen trichloride. What is the formula? NH3 plus we get the hydrochloric acid. How to balance the equation? So first you have to make it 2 here, the product side 2 nitrogen trichloride. So how much chlorine is there? 6 chlorine. The reactant side make it, before that, how much nitrogen is there? 2 nitrogen. So make it here 2 nitrogen. Reactant side. How much hydrogen is there? 6 hydrogen. So the product side 6 hydrochloric acid. Now how much chlorine is there? 6 plus 6, 12. So make it 6 here. 6 into 2 is equal to 12. Equation is balanced. Next, this ammonia again reacts with hydrochloric acid. We get ammonium chloride. Ammonia, what is the formula for ammonia? NH3 plus hydrochloric acid, HCl gives NH4Cl. So how to balance the equation? How we can balance the equation? Ammonium means, all of you know that one, NH4Cl. So they are having only 1 chlorine. So the reactant side also only 1 chlorine. The reactant side, if we are changing 2 ammonia, means here also we can be changed at 2 ammonia. 2 ammonia. Now ammonia is balanced. Chlorine here also having 2, make it 2, the reactant side. Chlorine is also balanced. How much hydrogen is there? 8 hydrogen. So here also balanced. So please correct the equation. Next, formation of amides and nitrides. Formation of amides and nitrides. Here, we know that one, sodium. Sodium is one of an electropositive metal. Am I right? It can be donate an electron. This sodium, and also we can be take magnesium. Here, first I am taking sodium. Sodium on reacts with ammonia, we get sodamide. What's the formula here? NaNH2. And also, we get the hydrogen gas. How can we balance the equation? Here having H2 in the product side. So the reactant side, the ammonia make it 2 here. So how much ammonia is there? How much nitrogen is there? Two nitrogen. So make it the reactant side 2 nitrogen. So how much sodium is there in the product side? 2. So make it the reactant side 2. Now the equation is balanced. Second condition. Magnesium combines with ammonia. Magnesium formula Mg reacts with ammonia. NH3 we get Mg3N2. Magnesium nitride. Magnesium nitride formula Mg3N2 and also liberating hydrogen. So how much magnesium is there? 3 magnesium. Make it 3 magnesium the product side. How much nitrogen is there? 2 nitrogen. So to make it 2 ammonia there. Then how can you find out the hydrogen? Hydrogen having 6. 2 into 3 is equal to 6. Make it 3 into 2 is equal to 6. Next about metallic salt. One of the important question. How the ammonia reacts with the metallic salt. Metallic salt. Here ammonia reacts with the metallic salt. We get metal hydroxide. Okay, for example, I am taking one of the metallic salt, metal chloride, one of the metal chloride. I am taking example FeCl3, iron chloride, Fe, ferric chloride. Okay, this ferric chloride reacts with ammonium hydroxide. Ammonium hydroxide formula. Ammonium hydroxide formula NH4OH. NH4OH gives this ion combines with the OH, we get iron hydroxide. Ammonia combines with the chlorine, we get ammonium chloride. Am I right? This is one of the equation. Iron chloride reacts with ammonia hydroxide, we get iron hydroxide and ammonium chloride. What is the formula of iron hydroxide? FeOH thrice. Am I right? So thrice means ammonia also they are having only 1 hydroxide. We'll make it 3 here. So 3 hydroxide balance. Ammonia combines with this 3 chlorine, we get 3 ammonium chloride. So make it 3 ammonium chloride. Now the equation is almost balanced. This is one of an actual reaction. In our textbook, they are having an ionic reaction. In case of here, that is iron chloride, I am taking here Fe3 plus ion. Reacts with ammonia hydroxide, I am taking only the ammonia, that is NH4 plus ions. Gives in the presence of hydroxyl ion, we get Fe combines with OH. This OH we get FeOH thrice. FeOH thrice. So make it 3 here. 3 OH ions there. And also we get 3 ammonium. The second condition, this ammonia reacts with copper ions. Copper ions, I am taking Cu2 plus ion. We get one of the coordination complex. One of the coordination complex. What is the coordination complex means? We are here getting this copper combines with the ammonia. We get CuNH3 4 times 2 plus ion. 2 plus. The coordination chemistry, we know that one. How we are saying the ammonia name means NH3 can be said like that. Ammine, A-M-M-I-N-E, ammine. So as per here, His ammonia is act as a ligand. Okay, one of an ligand. Ligand means one of a molecule. It will be attached to the central metal atom. Central metal atom is copper. This is attachment to the copper. So we are saying ligand. It is enclosed in a square bracket. Ligands are enclosed in a square bracket. Okay. So ammonia, in the coordination chemistry, we are saying amine. How much ammonia is there? 4 ammonia. So you can be say 4 means tetra. Tetraamine, copper oxidation state is 2. Copper 2 ion. What's the name of the complex here? How much ammonia is there? 4 ammonia. Tetraamine, copper 2 ions. Okay. So I have to here 4 heavy, so make it 4 ammonia here. Cu2 plus ions. Okay. One of the coordination compounds. Next one. Formation of amines. Here, ammonia forms an ammoniated compounds. Ammoniated compound means I am taking one of the calcium chloride. Formula all of you know that on CaCl2 calcium chloride. Here, ammonia having 8 NH3 ammonia. These compounds we are saying ammoniated compounds. Here, ammonia compounds by an ion dipole attraction. Here, dipole means all of you know that on dipoles means 2 poles, one having positive and other side having negative. Here, the negative end of the ammonia, that is attracted to Ca2 plus ion. That we are saying ammoniated compounds. Here, one of the important point, ammonia is act as a ligand. I told that about the ligand. Ligand is enclosed in a square bracket. For example, Cu NH3 4 times 2 plus ions. Here, NH3 is act as a ligand. The coordination compounds such as, I am taking other example, some of the other example. CO NH3 3 plus. CO means cobalt. Okay, CO. C capital C small o means cobalt. Capital C and capital O means carbon monoxide. Okay, don't forget that. Here capital C small o, there is a cobalt. Here having ammonia. Now only I told that ammonia can be, say as per the IUPAC PEC in coordination chemistry means amine. How much ammonia is there? 6 ammonia. So 4 means tetra, 5 means penta, 6 means hexa, hexamine, cobalt 3 ions. Another one more example they are having Ag NH3 twice plus, we can be say Ag NH3 twice means diamine silver 1 ion. These are some example. Anyhow, when excess ammonia is added to the aqueous solution of copper sulfate, what's the formula of copper sulfate? CuSO4. When I am adding excess ammonia in the copper sulfate solution, we get a deep blue color. So one of the compound is obtained. What is that compound? Cu NH3 4 times 2 plus. What's the name of the compound? How much ammonia is there? 4 ammonia. So we can be say tetramine copper 2 ions. Next, we can be discuss about the structure of ammonia. We know that ammonia is surrounded by 3 hydrogen atoms. One of the nitrogen atom is surrounded by 3 hydrogen atoms. The atomic number of nitrogen is 7. First shell we can be accommodate 2 electrons. Second shell we can be accommodate 5 electrons. So nitrogen having 5 electrons. Out of these 5 electrons, 3 electrons are paired with hydrogen. So we get nitrogen paired with hydrogen. Can we draw like that? First we have to take nitrogen. One hydrogen paired, next hydrogen paired, the last one hydrogen paired. So remaining, it have 2 electrons. That is considered as a lone pair of electron. Am I right? Anyhow, one of the important point, what is the bond angle between the 2 hydrogen atom, one of the hydrogen atom and other one hydrogen atom? What is the bond angle? 107 degree. And about nitrogen hydrogen. Okay. Here nitrogen hydrogen, nitrogen hydrogen, nitrogen hydrogen. Here having about the bond distance. Nitrogen hydrogen bond distance is 1.016 Armstrong unit. Here ammonia is an pyramidal shape. Anyway, ammonia is regarded as a tetrahedral with one lone pair of electron, because they are having one lone pair of electrons, so we can be considered as a tetrahedral position. But it becomes a pyramidal shape. Don't forget that pyramidal structure of ammonia is which shape? The ammonia molecule is which shape? Pyramidal shape. What is the bond angle? 107 degree. Important point. What is about the bond distance? 1 point. That is a hydrogen bond distance is 1 point. Hydrogen bond distance is 1.645 Armstrong unit. Nitrogen bond distance is 1.016 Armstrong unit. Next, we can be learn about nitric acid. What is about the nitric acid? We know the formula of nitric acid is HNO3. HNO3. This is one of the strong acid, strong oxidizing agent, nitrogen agent. It reacts with metals, non-metals, and nitric acid having some applications. Before that, we have to learn about the preparation of nitric acid. Here we are using two preparation. One is about the laboratory preparation. Another one is about the commercial methods of preparation. What is about the laboratory preparation means? We are taking equal amount of potassium nitrate. Otherwise, we can be say equal amount of sodium nitrate. What is the formula of potassium nitrate? KNO3. Otherwise, we can be taken as sodium NaNO3, sodium nitrate. First I am taking potassium nitrate. What is the formula? KNO3. I am taking concentrated sulfuric acid. What is the formula? H2SO4. I am heating these two reagents I am taking. One is about that potassium nitrate and also concentrated sulfuric acid equal amount. So what is happening here? Hydrogen sulfate, that is sulfuric acid, is split up into H++ and HSO4 minus N. Am I right? So the potassium combines with potassium K combines with HSO4 minus, we get KHSO4, and hydrogen combines with NO3 to form nitric acid. This is our first method. Here, one of the important point, here the temperature is kept as low to avoid the decomposition of nitric acid. Sometimes the decomposition takes place. For example, decomposition means nitric acid HNO3 undergoes decomposed into NO2 plus water molecules plus oxygen. We have to balance the equation here. So the reactants had water molecules, make it 2 here. So 2 water molecules. So total how much hydrogen is there? 4 hydrogen. So make it the reactant side 4 hydrogen. So how much nitrogen is there? 4 nitrogen. So make it the product side 4 nitrogen. Now the equation is balanced. Here the decomposition is possible. To avoid the decomposition, the acid is condensed to fuming liquid. The fuming liquid is a colored brown. One of the color is about there. The liquid color is brown. Why? What is the reason means? The presence of some nitrogen dioxide. Why? It is obtained by the decomposition of nitric acid. Actually, the pure nitric acid is a colorless. They have no color, colorless. But due to the decomposition, it becomes a light brown color. Okay. So balance the equation. Next about commercial preparation. All of you know about the laboratory preparation is very important. Laboratory preparation is very important. Try to learn the question. But commercial preparation, this is a large scale preparation. Large scale preparation. Large scale preparation means this preparation involves 3 steps. First step is about that ammonia is converted into nitric oxide. Second step, nitric oxide is oxidized to nitrogen dioxide. The nitrogen dioxide undergoes hydrolysis, we get nitric acid. That means reacts with the water, we get nitric acid. The 3 steps. What are the 3 steps here? First step is ammonia is converted into ammonia and reacts with oxygen. The first step, ammonia reacts with oxygen, we get nitric oxide. Second step, nitric oxide is oxidized to NO2, nitrogen dioxide. The third step, nitrogen dioxide is reacts with the water, we get nitric acid. We know that nitric acid is prepared in a large scale using Ostwald process. What is about the Ostwald process means? The large scale preparation. Ostwald is one of the great scientists, okay? Preparation of nitric acid. Ostwald process, again, one more reaction also having about the Ostwald process for the manufacture of sulfur trioxide. That also having. Here, ammonia preparation. One of the ammonia, the previous day we discussed that ammonia prepared by Haber's process. What is about the Haber's process? 2 molecules of nitrogen combines with the 3 molecules of hydrogen. We get 2 molecules of ammonia. Am I right? The ratio is about that 1:3 ratio. Here we are applying temperature, pressure, catalyst. Catalyst means ion act as a catalyst, Fe act as a catalyst, and one of the promoter also having molybdenum. That already we learned that one. Here, in Haber's process, we are preparing ammonia. This ammonia On react with the oxygen means oxygen is obtained from air, am I right? Air having 21% of oxygen. Anyway, ammonia reacts with oxygen, we get nitric oxide, and also hydrogen combines with oxygen, we get water molecules, and also have to write the temperature, that heat change, how much is plus 120 kilojoules. We have to balance the equation. The reactant side, you have to make it, for easiest way for make it is you have to make it 4NO. So the product side comes to the product side, make it 4 ammonia. Now nitrogen is balanced. What about the hydrogen? 4 3s are 12. So come to the water molecule, 6 into 2 is equal to 12. What about the oxygen? Here 6 plus 4, 10. So make it 5 into 2. Now the equation is balanced. This is about the first step. What is about the second step? Nitric oxide, that is NO, on reacts with the oxygen, we get nitrogen dioxide, NO2. Am I right? NO plus O2 is NO2. So how to balance the equation? Product side make it 2 NO2. The reactions also make it 2 NO. Now the equation is balanced. This is about the second step. The third step, nitrogen dioxide on reacts with the water, NO2, that is NO2 on reacts with the water, we get nitric acid, and also we get NO. Okay. So how can we easily balance the equation? Come to the product side, make it 2 nitric acid, because the reactant side having water molecules, the H2O, 2 hydrogen having. So the product side we are make it 2 hydrogen. So how can you count the nitrogen? Here having 2, there having also 1. So 2 plus 1 is equal to 3. So make it 3 here. Now everything is balanced. Next about, what are the properties of nitric acid? First one, we know that one, it is a colorless gas. Try to learn the boiling. It boils at 86 degrees Celsius. It is completely miscible in water. Completely miscible in water. It forming a constant boiling mixture. It's about a 98% nitric acid. What is the boiling point? Means boiling point is about the 120.5 degrees Celsius. Here the fumic nitric acid contains oxides of nitrogen. The nitric acid contains oxides of nitrogen. Nitric acid decomposes on exposure to sunlight. It is converted into NO2, water molecules, and also oxygen. The pure nitric acid or its concentrated solution becomes an yellow on standing. Before I told you that pure nitric acid is a colorless, but it becomes one of the yellow while on standing. Okay. The nitric acid, it acts as one of an oxidizing agent. The oxidation state changes from +5 to lower, that is +5 to +4, +3, +2, +1, like that. Maybe it becomes -3 also. It goes to ammonia, it becomes -3 also. Here nitric acid can act as an acid, an oxidizing agent, and a nitrating agent. This is a very, very important point. A nitric acid acts as an acid because we know it is one of the mineral acid. It is an oxidizing agent because nitric oxide, that is NO, on oxidized we get NO2, we know that one. Nitrating mixture, nitrating agent. What is that one? Nitrating agent, nitration. The mixture of concentrated sulfuric acid and the concentrated nitric acid is called as a nitrating agent. Am I right? Concentrated sulfuric acid plus concentrated nitric acid is a nitrating agent. Nitric acid, it can be reacts with metal oxide to form metal nitrate, and also we get water molecules. This is one of the concept. As an acid, nitric acid is one of an acid. This nitric acid on reacts with metal oxide. Metal oxide, I am taking one of the oxide is called as a zinc oxide. Otherwise, I am taking iron oxide. Anyhow, the nitric acid on reacts with zinc oxide, we get zinc nitrate. We have to write the equation. What is the formula of zinc oxide? ZNO. This ZNO reacts with nitric acid, HNO3 gives. Zinc combines with nitrate to form ZN, NO3 twice. Hydrogen combines with oxygen to form water molecules. Please count that how much hydrogen having the product side, 2 hydrogen. So make it the reaction side 2 hydrogen. Now the equation is balanced. The one equation is enough, my dear children. Those who are interested, please learning. You can take the 2 equation. Iron oxide combines with nitric acid. What is the formula of iron oxide? FeO. Nitric acid HNO3 gives iron nitrate FeNO3 thrice plus NO, nitric oxide, plus water molecules H2O. So how can you balance the equation? The reactant side having 1 Fe, the product side also having 3 Fe. Sorry, reactant side having 1 Fe, the product side having 1 Fe. The reactant side having 1 hydrogen, the product side having 2 hydrogen. So first I am make it in the product side. How to balance the nitrogen? So make it 3 here. So 3 of I am making 3 here means 3 into 3 is equal to 9. 9 plus here having 1 nitrogen, NO. So here water molecules are having NO. So 3 into 3 is equal to 9. 9 plus 1 is equal to 10. So 10 nitrogen having. So make it the reactant side 10 nitric acid, 10 HNO3. How much hydrogen is there? 10 hydrogen. So make it 5 here. Hydrogen is balanced. So how much iron is there in the product side? 3. So make it 3 here. Now the equation is balanced. Once again, please look the equation. FeO plus HNO3 gives FeNO3 thrice plus NO plus H2O. So first I am converting here the product side, make it 3 here is 3 FeNO3 thrice. The reactant side also you have to change here 3 Fe. So 3 Fe balance. How to count the nitrogen? Product side 3 into 3 is equal to 9. 9 plus 1 is equal to 10. So make it 10. The product side also make it 5 molecules of water. Okay, these are the questions. Today Our assignment is structure of ammonia. Structure of ammonia. Second one, preparation of nitric acid. There is a lab preparation is enough. Lab preparation of nitric acid. 2 questions. Thank you all of you. Thank you. Have a nice day.